All right, welcome to class, everybody. So our lesson today is section 3.4, which is about graphing inequalities for two variables. So we've been doing equations with two variables where we would graph lines that represent all of the solutions to two variable equations. And we're going to be doing the same type of thing. We're just moving to inequalities instead of equations. So just as a heads up, our first test is next week on Wednesday, Thursday, and Friday. And I will be getting the study guide to you guys as soon as possible. I thought that it was not next week, but the week after. So I was like, oh, I have plenty of time. And I realized I don't actually. So I will be getting that to you guys as soon as possible. But that will be next week in the testing center on Wednesday, Thursday, Friday. So with section 3.4, let's start with a really simple inequality that has two variables. So we have y is greater than or equal to x. So since we have two variables, our solutions are going to be ordered pairs. And I want you guys to think of an ordered pair that would make this inequality true. And when you've got one, just go ahead and raise your hand and we'll graph it. Yes. 0, 0. Yep, that would work because 0 equals 0. And so if we plugged x is 0, y is 0, that would make a true statement. Any other solutions to this equation or inequality, I mean? Yeah. Oh, 1, 1. Yep, that would be a solution. What was yours? Yeah, so like not only is 0, 0 a solution, but you could also have y is 1 and x is 0. So like this would be a solution. This would be a solution. Is that what you meant by going up the line? Yeah, so all of these points would be solutions. And same thing with this one. Any point above here would also be a solution, right? So all of those would be solutions. What other solutions would be possible? Are there any negative number solutions?
I think it's the same thing with the negatives.
Mm-hmm. Yep, like you could have -1, -1, -2, -2, -3, and then all of the points above those. So the thing with inequalities is they have an infinite number of solutions, but they have more infinite solutions than equations do, right? Because like equations, you would just have these points. Like if this was an equal sign instead of a greater than or equal to, then you would have just like a line of points. Versus with inequalities, you have the line of points, but you also have a whole bunch of points above it, or sometimes it's below it, depending on what the inequality is. And so the way that we graph these is we first start by graphing the boundary line, which is where they're equal. So like in this case, our boundary line would be this line right here, because these are all the points where y equals x. And so you'd have those solutions, and then you would have everything above it would be a solution. So the reasoning kind of behind this is like, if you think about less than versus greater than, equal is kind of the boundary between there. Because like if you, let's say we have the number 5, you know, you have a whole bunch of numbers that are less than 5, like 0, 1, 2, 3, even like the negative numbers. All of these are less than, and then as soon as you hit 5 equals 5, then you transition into 6 is greater than 5, 7 is greater than 5, 8 is greater than 5. And so where two expressions are equal, that's the boundary between the numbers being greater than or less than. So if we had a more complicated equation like this one, we could come up with a couple solutions just by randomly checking numbers. Like I might say, well, if x is 0 and y is like -2 or something like that, that would make it true because 5 times 0 is 0, 0 minus 1 is -1. -1 is greater than -2 is. And so this point, 0, negative, oh, sorry, actually I did that the wrong way. 0, -2 would actually be this point right here. So that would be a solution. And there's lots of other solutions that we could come up with, right? But the way that we graph all of the solutions is we first look at the equation y equals 5x minus 1, because that's going to be where the boundary is. And so we say, okay, well, where are some points where y equals 5x minus 1? So one of the things that so this equation is in slope intercept form. So we automatically know the y-intercept is -1, right? Because slope intercept form gives us the intercept. So on the equation, that would be a solution, which makes sense because if x is 0, then y would have to equal -1. What's another point on the line? Perfect. Yep, we could use the slope because the slope is 5. So I can say the slope is going to be 5 over 1. So I'd go up 5 and over 1. So this point would be on my line. Sorry, what? 1, 4. Oh, yeah. Yep. So 1, 4 would be on the line. And you could also find that you don't have to get that from the slope, because you could say, well, if x equals 1, what does y have to be? And you would still get that y equals 4. So you can either get that from the slope or from just by plugging in some number to find the solution. So this line right here is the boundary between greater than and less than, because that's where it's equal to. Now, the reason I did a dotted line is because these points are actually not solutions to the inequality they gave me. Because like if I took, let's say x is 0, y is -1, so this point right here, if I plug that in, I would get -1 is less than 5. Well, sorry, that's a 0. I get -1 is less than 0 minus -1, which is false. That is a false statement because I didn't have an or equal to line under here. So I'm going to use a dotted line to show that the points along that line are not solutions, but everything on one side of it is. So it's kind of like in one variable inequalities, when we had something like x is less than -1, how we would say, well, -1 has an open circle and then it's everything up to that open circle. So you could do like -1.1, but you can't do -1 itself. It's kind of a similar idea. It's just kind of like the two-dimensional version of it. So the dotted line is like a two-dimensional version of an open circle. Is everybody good with that? Okay, cool. So now that I've graphed my boundary line, now I just need to figure out which side of the line has the solutions. Now, in this case, I know that this is a solution. So that kind of just tells me it's going to be this side. But you can choose any point on this side of the line. So like I could say, 6, 2. I could try plugging in, I could try plugging in x is 6, into the equation they gave me. So if x is 6 and y is 2, well, 2 is less than 30 minus 1. And so that would be a solution. And basically any point on this side of the line is going to be a solution. So this graph would represent all of my solutions to this inequality. So let's do a quick check-in on this. On a scale of 1 to 5, how are you guys feeling about this? Okay, are there any specific questions that you guys have? Like any part of the process that you're wondering about?
Shading, it's just kind of
like trying to know which side to shade? Yeah, so the way you figure it out is you just choose a point on one side of the line and you plug it in and see if it makes the statement true. If it makes it true, like on this one, I had plugged in earlier, the point 0, -2, that made the inequality true. And so that told me that the side of the line that that point was on needed to be shaded. If I had plugged in because I mean, this was something I had done earlier, but like if I hadn't done that, maybe, I'm gonna have to plug that in. But if I wouldn't know until I plugged something in. So maybe I might have chosen like this point. And I would have said, if x is 0, maybe I'll do this in red because we already know it's not a solution. Like if I had said x is 0, y is 5. Well, if I plug that in, I would get 5 is less than 5 times 0 minus 1, which is 0 minus 1 is -1. Well, 5 is not less than -1. That's a false statement. And so that would tell me I don't shade that side of the line. Okay, so to summarize, if you want to add these to your notes, in one dimension, when we graph inequalities, if we have a less than or equal to sign, we do a closed circle. So we have closed circles for these two types of symbols and open circles for these two. So for two-dimensional inequalities, you have dotted lines for less than or greater than, and solid lines for like less than or equal to for the boundaries. So let's say that we wanted to graph a line like this one. Where do you guys think we, or inequality like this one? Where do you guys think we would start?
R splitting Y.
Okay, yep. So we could do that, and we could do that with the inequality. So like we could subtract 3x from both sides, then divide by -4. The main thing you'd want to watch out for if you do that approach is that if you divide by a -4, you got to switch the inequality. So you could totally do that. There is another method you can use as well that I kind of prefer, but your way would totally work.
So we do the same thing with the X and the Y, just plug in. -3 is Y.
Mhm.
Do the same thing for Y, you plug in 0. and have a 4.
Yep. Yep, exactly. Because so ultimately, regardless of whether you isolate Y or if you find the intercepts, like what you're saying, what we ultimately want to do is graph the boundary line first. And then after we have the boundary line, we decide which side is shaded. So I'm going to graph the equation. So I'm not treating it like an inequality right now because the boundary is where they're equal. So I'll say, okay, well, I could solve for Y like you were saying, or your method is how I prefer to do it, of finding the intercepts. So when X was 0, what did you say Y was? -3. Okay. And then if Y is 0, then X would be 4. So that basically gives us our X and Y intercepts. So we have a Y intercept of -3 and X intercept of 4. And when I connect these two dots to form my boundary line, is it going to be a dotted line or a solid line? Yep, dotted. Because my inequality is a less than inequality, which means that the places where the two parts are equal to each other won't actually be a solution. So I use a dotted line to represent that. And now I need to decide which side of the line to shade. So for me, I like choosing easy points to plug in. So like I might choose to plug in 0, 0 because zeros are usually really easy numbers to plug in. And when I do that, I get 0 times 3, which is 0, minus 4 times 0, which is 0. So I essentially get 0 minus 0 is less than 12. Is that a true statement? Yeah, it's true that 0 is less than 12. And so that means that this side of my line is shaded. Now, if it had been a false statement, then that would have told me that that side of the line has non-solution, so I would shade the opposite side. But since this case it was true, then that just tells me that that's the side that I would shade. And you would get the same answer if you had done it with your method, because your method would give you the Y-intercept and then you could use your slope to find the other point. So if you prefer that, you can totally do that. So in this one's actually already solved for Y, so we could use that method to graph it. So I'm going to graph the equation Y equals 3/5 X minus 2. And in this equation, everybody call it out. What's the Y-intercept? -2. And what's the slope? 3/5. And so the 3 is representing my rise. So I'll go up 3 units and then I'll go over 5 units. So that's another point on my line. And this is my boundary line. Remember, the equation is where the boundary is. And should this boundary be a solid line or a dotted line? Yep, good job, solid. And now I need to decide which side of the line to shade. So I have 0, 0 again. Sometimes you won't be able to plug in 0, 0 if your line goes through 0, 0, because it won't be on like a specific side. It will just be like on the line. But in this case, it happens to be not on the line, so I could plug it in. And if I plug in a 0 in this case, I get 0 is less than 3/5 times 0, which is 0, minus 2. Is that a true statement? Yep, I'm seeing some head nods. So that is not true, which means this is not a solution, which also means everything on that side of the line is not a solution, because this line is the boundary between solutions and non-solutions. So if that one point is not a solution, everything else on that side of the line will not be, and this side of the line will be the solutions instead. And if you wanted to check that, you could choose a point that's somewhere in this range and plug it in, and it would make it true. But I like to choose numbers that are easy to plug in. And in this case, 0, 0 was an easy one. Any questions on that? Yeah. Okay. Yeah, so this number right here is the slope of the line, and that's only because this is in slope-intercept form. If it's in a different form, like in this one, it's not necessarily a slope of 3, but because it's in slope-intercept form, that's the slope. And the slope is calculated as the rise over run, and this is going to be a +3 over a +5. So I started at my y-intercept because I know the y-intercept is a point, and then I went up 1, 2, 3 units for my rise, and then I went over 1, 2, 3, 4, 5 units, and that gave me my second point. I mean, technically, you could also do a rise over run of -3 over -5, because that still equals 3/5, but having and you would still get the same graph because you'd be going down 3 and backwards 5, which would be like over here. So you'd still get the same line. I think it's easier to work with positive, so. Any other questions? All right, so a bunch of problems on your homework will look like that. And then some of them will also look like this, where they'll give you the solutions and you have to find the inequality that describes it. So the process is still the same. You're still going to focus on the boundary first and then decide which side of the line, or like which side your inequality should be directed towards. So in this one, I'm going to start by looking at my boundary line, and I can see that I have a y-intercept of -2, and looks like this might be a good point to help me find my slope. So from here to here, I have a rise of 4 and a run of 1. And so that means that my slope of my line is going to be 4 over 1, which just equals 4. And then my y-intercept, I said earlier, was -2. And so the equation of this line would be y equals 4x minus 2, if I put it in slope-intercept form. However, this graph does not represent an equation. This represents an inequality, because if it was an equation, it would just be a single line and there wouldn't be any shading. And so in this case, I need to replace my equal sign with a greater than or a less than symbol. And in this case, is it going to have an or equal to line under it? No, because it's got a dotted line. So it's just either going to be greater than or it's going to be less than. And the way that you decide which side it's going to be on is you take a solution to it. So remember, this graph is showing us all of the solutions to the inequality we're supposed to write. So you can just choose one of the solutions. So maybe I might choose this one. This solution is 3 on the x-axis, 0 on the y. And because it's in the shaded area, it needs to be a solution to whatever inequality I write. And so I'm going to say, okay, well, if y is 0 and x is 3, I'm going to get 0 and 12 minus 2, which is 10. So show me with your fingers, should it go this way or this way? My inequality to make it true. Yep, good job. It's going to have to go this way in order to make 10 greater than 0. And so my inequality here needs to look like this. Does that make sense? How to find that? So the process is kind of the same. You look at the boundary. If they give you the graph, you find the equation of the boundary. And then after you found the equation for the boundary, then you figure out which way your inequality needs to go based on what your solutions are. If they give you the inequality and you graph it, you still go through the same process. You find the boundary and then you decide which side is shaded. So any questions on that? Okay. So this one, again, basically kind of what we just did. The only difference is on this one, you're going to have like a greater than or equal to symbol instead of just greater than, because the line is a solid line right here instead of a dotted line. So that's pretty much all you need to know to be able to do your homework. So here's that summary page again. And these two yellow boxes kind of describe the process that you do, regardless of whether they give you the graph and ask for an inequality, or if they give you the inequality and ask for a graph. So if you want to add those to your notes real quick, go ahead. And then you can open up your homework. And I'm going to start on question 7, because question 7 is kind of a unique situation. All right, so on my number 7, I have the inequality x is less than or equal to -6. And this one's a little bit different than the ones we were working with, just because there's not a y in it. But we still go through the same process for graphing it. So I'm going to think about, how would I graph the line x equals -6? Show me with your arms, what would that look like? Yep. Yeah, so it's because remember, like if you don't have two variables, it's either going to be like a straight up and down graph if you have x equals something, or it will be a horizontal graph if you have y equals something. And the reason for that is because all of the points along this line are going to be the points where x equals -6. And any other point will not be where it equals -6. And so that is going to be my boundary line. And then when I'm trying to check and see, well, which side of the line do I shade? Because what they asked me to graph is actually an inequality. Then maybe I might choose 0, 0, because that's always my favorite point to graph. And if I plug that in, I get 0 is less than or equal to -6, because there was no y to plug the 0 in for. And that's a false statement. And so that means that point is not a solution. So I would shade the other side of the line instead. And when you're graphing these on XYZ, these two buttons down here are the ones that you'll click to determine whether it's a solid line or a dotted line. Because like some of the graphs like this one require a solid line since it's less than or equal to, and then other ones require a dotted line. And when you graph it, it will require 3 points. So like on this one, I would choose this button, and I'm going to graph 2 points on my line. And it doesn't matter where on the line the 2 points are, you just have to graph the 2 solutions. And then your third point is what needs to be on whichever side you want to be shaded. So like I would put this point and then this point, and then I'd click some point in the shaded region to show the computer system that you want that side of the line to be graphed. So maybe try that out on your own on question 7 to kind of see how that works. And question, I think it was 8. is kind of similar to this, except it only has a Y instead of just an X. So on question 8, it will be like a horizontal line instead of a straight up and down one. Yeah, which question number is it?
Same one, but
Oh.
I did the same thing as you did, and it's not.
Yeah, so that point is not actually a solution, because if you plug in X is -6, that makes a false statement.
Okay.
Yeah, because my inequality is going the other direction.
Yeah.
Cool. Another one I wanted to go over was question 9. So on question 9 for my numbers, and again, you're welcome to follow along with me if you want, or you can just work on your own. But for mine, I have y is less than 3x. So I first need to graph my boundary line, which is going to be y equals 3x. And because I don't have a less than or equal to symbol, I'm going to have a dotted boundary line. And so to graph this, I might say, okay, well, I could do this with slope intercept form, or I could just find the intercepts. So I might say, okay, well, if x equals 0, then y has to equal 0 as well. And so to find the other solution, I have to plug in some other number that's not zeros, because if I said, well, y equals 0, then like you're going to get the same point. So I might say, like, what if x is 1? Well, then y would have to be 3, which would be that point right there. And you could also get that if you had thought about this in slope intercept form, because in slope intercept form, you essentially have like a +0 after that, which means your intercept is at, like your y-intercept is at 0, and then your slope of 3, which you could write as 3/1, would go up 3/1. So there's multiple ways you can graph that. But in any case, you end up with a graph that looks like this, and you'd want it to be a dotted line. And on this one, so on all the examples I did in class, I would always choose to plug in 0, 0. But this is one of those situations where 0, 0 won't help me decide which side to shade, because 0, 0 is on the line. And so you're just going to choose some other number that would be easy to plug in. So maybe I might choose this point, and I'd say, okay, well, if x is 2 and y is 0 less than 3 times 2? And in this case, it is. So that would tell me I would shade this side. But if it had been a false statement, then I would shade the other side. So my little trick of using 0, 0 as like my testing point doesn't always work if 0, 0 ends up being on the line, because it won't help you determine which side of the line to graph. Yeah. Okay, which question number is it? 1. Okay. And what is your equation?
X plus y.
Greater than -1? Okay. And is it greater than or equal to, or just greater than?
Is greater.
Okay. So how did you solve it?
So.
Okay. Okay. Oh, gotcha. Yeah, that would make a difference. Yeah, because your graph, I think, should end up looking something kind of like this. And then you'll have a dotted line. And then I think it would be the lower half of the graph. maybe.
And
Yeah.
what you get.
Oh, is it the upper half? Oh, right, because it's a negative one. Yeah. I plugged in 0, 0, and I mixed up the negative again. Yeah. Any other questions you guys would like me to go over? Yeah, which number? Oh, yes, the word problem one. So question 15 is a word problem. So if you guys would like to go to question 15 and do this with us, you're welcome to. So on this one, it says you have two cars. The first car travels an average of 16 miles on a gallon of gasoline. Your numbers might be different, but this is for the first car. And the second car averages 26 miles per gallon. And then we know, or we're asked, suppose that you can afford to buy up to 35 gallons of gas. So that's where our inequality is going to come from, is like you can earn, or like you can afford to buy up to 35 gallons of gas. It could still be less than 35 gallons of gas though. So that's where our inequality is going to come in. And then it says if the first car is driven X miles, so I'm color coding these to make a match, and the second car is driven Y miles, shade the region that gives all the possible values of X and Y that will keep you from buying more than 35 gallons of gas this month. So essentially the structure of the inequality we want to set up is we want to have the gallons for car 1 and the gallons of gas for car 2. Those together have to be less than or equal to 35. Is everybody good with where I got that basic structure? Because it's like you can only afford to buy up to 35 gallons of gas. So the gallons that you buy for each car needs to be less than or equal to 35. Well, so X isn't the number of gallons. X is the number of miles that are driven. And so to find the gallons of gas that car 1 uses, you're actually going to do X divided by the gas mileage. Because like, let's say you travel like 100 miles. Well, you don't need 100 gallons of gas to travel 100 miles. You would split 100 miles up into groups of 16 because car 1, oh, I should probably actually color code this. So car 1, still didn't get the right color, sorry. So car 1 travels X miles. We don't know what X is. Like that's one of the things we're trying to find. But X represents the number of miles, and you want to divide it up into groups of 16 to figure out how many gallons it takes to go that number of miles. And so that would be the number for that. And then for the second car is being driven Y miles, and its gas mileage is 26 miles per gallon. So you would divide by that, and that needs to be less than or equal to 35. So you could have it set up like that. I personally think it would be easier to graph it if you didn't have fractions. So in this case, I would multiply by something that would cancel out all the fractions, which I don't actually know what the common denominator of 16 and 26 is. It may not be the least common denominator, but what's 16 times 26? Because that would work. 460.
416.
416. Okay. Oh, 416. Sorry. Have bad hearing. Okay, so if I multiply both sides by 416, then that should give me 26x plus 16y. It may not be the least common denominator, but it will still work. And that needs to be less than or equal to what's 416 times 35. And your guys' numbers will be different, like whatever your numbers are. 2,000, 14,000, 560, like that. Okay, awesome. So I personally enjoy not working with fractions. So whenever I have equations or inequalities with them, I like to multiply both sides to get something like this. And in this inequality, I want to graph the equation to find the boundary line. So the equation is going to be where 26x plus 16y equals 14,560. And so if x equals 0, then y is gonna have to equal whatever that number divided by 16 is. What is that? 910. Okay, and then if y is 0, then that number divided by 26 would be 560. Okay, awesome. So that tells me my my y-intercept is 910, which is going to be like right here. And my x-intercept is going to be 560, which is right here. And so depending, I'm not sure how finicky it is on like getting it exactly on those points. So if you're having trouble graphing those points, you could also plug in numbers that are not 0 that would give you whole numbers. That would also work. But basically, this line is going to represent all of the number of miles you could drive in each car, where if you spent exactly 35 gallons of gas. And then because you want it to be less than, it's going to be this region down here. Because you could drive 0 miles in both cars because you wouldn't buy 35 gallons of gas in that case. And in this problem, technically, these points over here make no sense because you can't drive negative miles in a car. They're still in the solution set, like on your graph, they'll still be graphed in them, but it really mostly makes the sense for, or it makes the most sense for your answers to be kind of in that black shaded region, because that's where you're driving a positive number of miles. Because remember, the x-axis, they told us, represented how many miles the first car is driven. The y-axis represents the number of miles the second car is driven. So that's how you would solve that problem. Does anyone have any questions on that? I know there's a long explanation. The first part, yeah.